Okay, so this is question 5. We're given a graph of f of x, which is equals to ax squared plus bx minus 10, and we're also given the graph of g of x, which is m over x plus p plus q. So we're having a parabola and a hyperbola, and we're also given a point of 5 and 0, and we also given D. We are told that those 2 points are actually x-intercepts of f, and E is a turning point of f, which is 3 and k. The vertical asymptotes of G intersects the graph of f at 5 and 0. The horizontal asymptote of G intersects the f graph at the y-intercept. So we have all the information, and the diagram below is given. So let's answer the following questions. So the first question says that we should write down the coordinates of the y-intercept of f. Remember that our f graph is given an equation of ax squared plus bx minus 10. So to find the y-intercept when x is equals to 0, we're going to say fx equals to 0 is equals to our a into 0 squared plus our b into 0 minus 10. So the answer here would be minus 10. So the coordinates would be 0 and minus 10. So now we are asked to write down in 5.2. 5.2 says that determine the coordinates of D, the x-intercept of f. So remember that D is one of the x-intercepts, so it's here, the x-intercept of the parabola. So we want to identify the coordinate. We know very well that the y value of D is 0, so we want to find the x value. So to find the x value, we should remember that the parabola is symmetric. So the x value of the turning point here is equals to 3, and we know that the x value here is equals to 5, and we want to identify the x value of D. So we can use that symmetry to find the value of xd. So what we can do is we can find the difference between x of d and the turning point, and which will be equals to the difference here of the turning point and this 5 here. So what I mean by is the x of the turning point has a constant difference with the x-intercept, so meaning it divides them. So what we can do is the x, which is this one here, is actually the x of 5 minus the x of the turning point will give you the difference, x of difference. So meaning the 5 minus the x value of the turning point is 3, so we're going to get 2. So we know very well that the difference is actually 2 between x, which is equals to 5, and the turning point, and the turning point and x of d. So to find the difference between the x-intercept and the turning point is equals to 2, right? So what we can do is this, because we want x of d and we know the difference is equals to 2. So what we can do is, to find x of d, we have to say x of d is equals to the turning point, the value of the turning point, which is equals to 3. We're going to minus with the difference of. So what we can do is the x of d is equals to the turning point minus the difference, which is 2. So x of d is equals to the value of the turning point, which is 3, minus the difference, which is 2. So x of d is equals to 1. So therefore d, the coordinates of d will be 1 and 0. So 5.3, we are told to show that the 5.3, we are told to show that the equation of f is equals to minus 2x squared plus 12x minus 10. So for us to show that, we should know our intercepts, and the turning point, we don't really need it to actually find the equation. So the x-intercepts are important, and we know that our d we found to be 1 and 0, which is one of the x-intercepts, and another x-intercept that was given is 5 and 0. So we have these two intercepts, and our f we were initially given as f of x is equals to ax squared plus bx minus 10. So having this information will help us to identify the equation of our parabola. So to find our equation of f, we know very well that f of x is equals to ax squared plus bx minus 10, meaning that our y-intercept is actually y is equals to minus 10. So in coordinate form, it's 0 and minus 10. And we know our x-intercepts that we found to be 1 and 0, and the given one is 5 and 0. So you're going to use the equation of f of x being equals to a into x minus x1, x minus x2. Our f of x, we're going to write this minus 10. So it's going to be minus 10. And then where we see x, we're going to put 0. So it's going to be a into 0 minus x1, 0 minus x2. So where there's x1 and x2, we're going to put our intercepts, which is 1 and 5. So it's minus 10 equals to a into 0 minus, we're going to put the positive 1, so it's going to be 1, and 0 minus, we're going to put positive 5. So we have minus 10 is equals to a into, so 0 minus 1 is going to be minus 1, 0 minus 5 is going to be minus 5. Then now we have minus 10 is equals to, so minus 1 times minus 5 is going to give you 5a, then divide by 5, our a value is equals to minus 2. So this is our a value, so we're going to substitute the a value here. So meaning that we're going to have our f of x being equals to our a value, which is minus 2, into x minus our intercept, which is 1, and x minus our intercept, which is 5. So this is the equation. So we're going to continue to solve it. So we're going to say f of x is equals to minus 2 into x minus 1, x minus 5. So you're going to use the FOIL method to find the solution for this portion, and then later multiply with this 2 here. So we have f of x, it's equals to minus 2 into, so FOIL method is going to be x multiplied by x is going to be x squared, x multiplied by minus 5 is going to be minus 5x, and then minus 1 multiplied by x is going to be minus x, and then minus 1 multiplied by minus 5 is going to be positive 5. Then equals to minus 2 into x squared, we add the like term, so it's going to be minus 6 plus 5. And then our f of x, we're going to be equals to, so this minus 2 will multiply everything that is inside, so it's going to be x here. So it's going to multiply everything that is inside, so it's going to be minus 2x squared plus 12x minus 10. Right, so our f of x for this graph is minus 2x squared plus 12x minus 10. So this is our equation of f of x. So now 5.4, we are asked to calculate the value of k, the y coordinate of the turning point. So if you can see here, it is the y value of the turning point. We already have the x value being x equals to 3. So we just want the y value of the turning point. So to find our y value of the turning point, remember that our f of x that we calculated in initial equation. So to find our y value of the turning point, remember that the f of x which we calculated initially is minus 2x squared plus 12x minus 10. And we already know the x value of the turning point, which is equals to 3. We're simply going to substitute that x equals to 3 into our f of x to find the y value of the turning point. So if you punch your calculator, you will find that the y value of the turning point is equals to 8. So therefore our k value is equals to 8. We are going to do 5.5. Says that determine the equation of g. So the equation of g, it is of the form g of x is equals to m over x plus p plus q. So this is your hyperbola. So we're going to find the equation of this hyperbola. So let's have a look at the information that we have for this hyperbola here. What we need to note is that this hyperbola intersects the graph of f at the turning point and at this point here. So we already know that the point of this hyperbola is 3 and 8. Since we found that the k value is equals to 8 in the initial equation, in the initial question, sorry. So we have the point for the hyperbola, and what we need to note is that where it intersects the, and another thing that you need to note is that this dotted line here that we see moving, this dotted line here, we know that it is actually a y-intercept for the graph of f, and in the initial question we found that that y-intercept is actually equals to minus 10. So but for the parabola, since you can see it does not touch this line here, so it means now this is actually the horizontal asymptote of the hyperbola. So we're having the horizontal asymptote, and we're also having a point to actually find the equation of this hyperbola here. And also what you need to note is that this dotted line here that is moving downwards like that, it is actually the y-intercept of the graph of f, but it is also the vertical asymptote of the hyperbola. So we're having the vertical asymptote, which is equals to 5. We're having the horizontal asymptote, which is equals to minus 10, and you also have this point here. So having these three we'll be able to solve or find the equation of the hyperbola. So we're having the horizontal asymptote. So to solve the problem, we have the horizontal asymptote. So to solve the problem, we're having a point of 3 and 8 for the hyperbola, and we have the horizontal asymptote of -10, and we have the vertical asymptote of 5. And we know that the g of x is equals to m over x plus p plus q, right? And we're going to substitute the asymptote, so it's going to be g of x is equals to m over x. Because the vertical asymptote is positive, if you take it to the other side, it's going to be -5, and the horizontal asymptote is -10, so we're going to write -10. So for us to complete the equation of this hyperbola, we need to find the value of m. So we're going to use the point of 3 and 8 to find the value of m. So we're going to substitute this point, and we're going to say 8 is equals to m over 3 minus 5 minus 10. So we're going to have 8 is equals to m over 3 minus 5 is -2 minus 10. Transpose the -10 to the other side. We have 8 plus 10 is equals to m over -2. 8 plus 10 is 18, is equals to m over -2. Then we cross multiply, so our m is equals to -2 times 18, right? So our m is equals to -36. So therefore our equation of g of x is equals to our m, which is -36 over x minus 5 minus 10. So this is the equation of g of x. 5.6 says that calculate the y-intercept of g. So we calculated the equation of g in the previous question, so now we'll find the y-intercept. So remember that our graph of g of x is equals to -36 over x minus 5 minus 10. So to find the y-intercept when x is equals to 0, so it's going to be g of x equals to 0 is equals to -36 over 0 minus 5 minus 10. So you're going to punch your calculator and you will find -14 over 5, which approximate to -2.8. So to write in coordinate form, we have 0 and -2.8 as our y-intercept. 5.7. If h is the decreasing axis of symmetry of G, determine the equation of h in the form of y is equals to mx plus c. So when they say it's a decreasing axis of symmetry, so in the hyperbola we have two axes of symmetry. We have a positive axis of symmetry, which has a gradient of +1. We have a negative axis of symmetry, which is a gradient of -1. So for us to find the equation of our axis of symmetry, whether positive or negative, we need to use y is equals to mx plus c, knowing the value of m. So if it's positive axis of symmetry, it's going to be x plus c. If it's a negative axis of symmetry, it's going to be y is equals to -x plus c. So to find the value of c, we always have to substitute our coordinate of the asymptote. So we can have the horizontal asymptote coordinate and the vertical asymptote coordinate. So we'll substitute these coordinates to this coordinate rather to find the value of c, so that we can complete in finding the equation of our axis of symmetry. So in this question, we are asked to find the decreasing axis of symmetry of G. So meaning that we're going to focus on m is equals to -1. So to complete in finding our axis of symmetry, we know m is equals to -1, and our coordinate of asymptotes, we know it's 5 and -10, right? And Another thing that we'll need is our y is equals to mx plus c, knowing very well that our m is equals to -1, so it's minus x plus c, and then we substitute our point, which is our horizontal and vertical asymptotes. So this is the vertical asymptote, this is horizontal asymptote, so of 5 and minus 10, and then minus 10 is equals to minus into 5 plus c. So transpose the minus 5 to the other side. We have minus 10 plus 5 is equal to c. So therefore our c is equals to minus 5. So to complete our equation, we want to say y is equals to minus x minus 5. So this is your equation that is decreasing the decreasing axis of symmetry of the hyperbola. So now 5.8, we are asked to calculate the x-intercept of G. So to find the x-intercept of G, we know that G of x is equals to minus 36 over x minus 5 minus 10. So x-intercept when y is equals to 0, so it's going to be 0 is equals to minus 36 over x minus 5 minus 10. We transpose the 10 to the other side. We have 10 is equals to minus 36 over x minus 5, and then we cross multiply. I'm going to have 10 multiplied by x minus 5 equals to minus 36, and then we divide by 10 both sides. We have x minus 5 is equals to minus 36 over 10. And then we're going to transpose the 5 to the other side. We have x being equals to minus 36 over 10 plus 5, and the final answer is going to be 7 over 5. So this is the x-intercept of the function here. So it's going to be 7 over 5 and 0. So 5.9, we are asked for which values of x will the function of f multiplied by the function of g give you solution of y which is less than 0. So less than 0 meaning the solutions of y should be negative, right? Cool. So let's go to our graph here and see this problem here. So what you need to note is first here the point of the y-intercept, we know now that it is 7 over 5 and 0, and here and then we need to note that here the y-intercept is actually 0 and minus 10, right? So we want to find the solutions of x when the f of x multiplied by the g of x will give you less than or equals to 0. So to really identify that case is you have to look, okay, fine, we're having the y values of the f of x. So let's say we look at this portion here, the y values, the sign of the y values of this intercept, the y values are negative here, negative throughout up until they reach this point. They're all negative, and the y values of the hyperbola are also negative. So if you were to multiply negative and a negative will give you positive. So that's what we are not looking for. But if we have a look here, but if we have a look here at this point here, so we know at D has coordinate 1 and 0, right? And if we have a look at just this portion here, this small portion here, so let me erase this one here. So if you have a look at the boundary that I've just set, between this boundary, which is the blue line, you need to note that the y value of the hyperbola, it's positive here. Going down, it's positive, going down up until this point here, right? And the y value of the hyperbola, it's positive here, positive here, positive here, positive here, positive here, positive here, up until x is equals to 7/5, and then it starts to be negative, 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 right? So let's look, because we want to multiply f with g and give us a solution that is less than or equals to 0, so basically a solution that is negative. So if you take a look, so what we can do here is this: we can multiply these positive values here, these positive values. If you multiply them with these negative values, then we'll definitely get a solution that is less than 0. So if you multiply a positive and a negative, you definitely get a negative. So which means we need to focus on that and neglect this portion here, neglect this portion here up until this point where we reach x is equals to 7/5. So we're going to neglect this point here. We neglect it. We look at this part and this part here. So where does that happen? So if I erase the part that we are neglecting and we focus where now x is actually equals to 7/5. So meaning I need to create a boundary here, a boundary from this point going downwards. So this boundary will have another boundary. So let me just erase everything here so that it becomes neat for you to see. So now at this point we know x is equal to 7/5. So I'm going to create a boundary going up like that, and I'm going to create another boundary at d, which is equals to 1 and 0. I'm going to do like this. So as I've indicated, we know that for f the y values here are positive, but now for g the y values here are negative, which is what we are looking for. We want to find a positive value, multiply it with a negative value of y to give us a negative value of y. So this is where the solution, the situation happens, where we have positive values multiplied with negative values will give us a solution of negative value. So what are the x values when this case happens? So you're going to use the d and this intercept of 7/5. So we're going to say when x lies between 7/5 and 1, then you're having solutions of y which are less than or equals to 0. So this is the solution for your question here. So therefore, since we're looking at the graph of f and g, and as I've indicated, we're going to look at the point between d, which is 1 and 0, and the other intercept, which is 7/5 and 0. So look at the between those 2 points. You can simply conclude, since I've explained that your x lies between 7/5 and 1. So this would be your solution of x. So 5.10 says that for which values of t will g of x for which values of t will g of x plus t equals to 0 have one negative root? So what you're going to do is this. You have g of x plus t is equals to 0. So you want to identify the values of t, right? But we need to note that, okay, fine, if you transpose this t to the other side, you have g of t being equals to minus t. So whatever value of t you have, it will be negative in terms of t, right? So remember that g of t, it's actually a y-intercept, right? It's actually a y-intercept. And if you remember, you recall the y-intercept of previous questions, we had a y-intercept which is equals to minus 2.8, and another y-intercept which is equals to minus 10, right? So the minus 10 was actually the horizontal asymptote, right? So we're having these two y values here, so which are actually equals to minus t. So if we say g of t is actually equals to minus 2.8, which is equals to minus t, therefore t will be equals to 2.8, right? Or if you say minus 10 is equals to minus t, therefore t will be equals to 10. So basically our t, the element of t lies between your 2.8 and your 10. So these are actually the values of t, 2.8 and 10. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.